Now, to derive a polynomial quickly without having to refer to many special products and the limit definition, you have to add more rules to your repertoire. The first one is the constant multiple rule, and the sum rule is the second one. And these are on top of both the constant rule and the power rule. So let me show you the proof of the constant multiple rule. That's very simple, and for some of you it's going to seem a little weird. So how are we going to do this? We're going to use the definition of the derivative of CF of x. How do we do that? We do CF, use the definition. So the idea here is that we're defining a new function, say g of x equal to CF of x, and then we're calculating the derivative g prime of x as the limit of g of maybe x plus h minus g of x over h when h goes to 0. So that's one way to do that. And now we have to plug back in to see what g of h is, right? Remember that I said g of x is c times f of x, so that will be c times f of x plus h minus c times f of x over h. So that's the limit when h goes to 0. If I factor out a c, that will be c times f of x plus h, all that divided by, minus f of x, all that divided by h. So I can bring the c out, and that comes from the constant multiple rule for limits. So I'm relying on the fact that the constant multiple rule is true for limits to show that it's also true for derivatives. And now this is c times this guy, and this guy, if you look at it carefully and closely, this is f prime of x. Okay, so this is my proof. One thing you are going to notice here is that we're going to change freely between notations. So dx of f of x is the same as f prime of x. Oh, this is going to happen frequently, so you can get used to it. So this is a proof for the constant multiple rule. And again, it relies on the equivalent rule for limits. Now we're going to do the same for the sum rule. It's pretty much the same thing. Just want to formally have it done. So how do I find? So now what I'm doing is I'm renaming, say, h of x as f of x plus g of x. So when I calculate h prime of x, I'm doing the limit. Maybe I shouldn't do h, because I'll do the limit when h goes to 0. So maybe I should not name this h. Maybe I'll do j of x. J of x is f of x plus g of x. So then the limit, the j prime of x is the limit when h goes to 0 of j of x plus h minus j of x over h. And then I got to remember what j is, and then plug in x plus h into j. So I'll save this, and then in my actual proof I'll do, the derivative of f of x plus g of x is the limit when h goes to 0. So I'm doing this now, but plugging in. So j of x plus h is f of x plus h plus g of x plus h minus, and then j of x is just this, so f of x plus g of x, all that divided by h, so that's the limit when h goes to 0. So I got to distribute the minus signs. And then I can next group the like terms to put f with f, so this f and this f, they go together. So f of x plus h minus f of x. And then I can split this up into two different limits. And then again, I'm using the sum rule for limits. So what's left are the h's. So what's left are these. All that divided by h. So that gives me this guy, which is f prime of x, by definition, and this guy, which is g prime of x, by definition. So this rule is proved. So how can I then use this rule to show that I can find the derivative of a polynomial quickly, right? So I'll do that slowly. Note that they replaced w or x with a w, and they're deriving with respect to w, but it's the same thing. Just pretend like x is w, you're going to get the same result. So d dw of this is 2w cubed, derivative of d dw of 2w cubed, so let me write it carefully. Okay, I'm doing d dw 2w cubed plus 9w squared minus 6w plus 4. So first I use the sum rule. So I do d dw of 2w cubed plus d dw of 9w squared plus d dw minus 6w plus d dw. So sum rule, I can apply one derivative to each. Now I can use constant multiple rule to bring out the constants on each. So that's 2 d dw w cubed plus 9 d dw, so the constants are jumping out, and then the 6 minus 6 jumps out, so minus 6 d dw. So all of these are the two rules that we proved in this video, and then now we're going to use rules that we've known from before, which are the power rule and the constant rule. So this is 2. So what is the derivative of w cubed? So it's power and w to the power minus 1. So the 3 comes down. 9. So w squared is 2w. So power comes down and the power minus 1. Minus 6 times. What's the derivative of w? It's just 1. So it would be 1 times w to the 0th. And then the derivative of 4 is just 0. So that's the constant rule. So now I can just reorganize this. That's 6w squared plus 18w minus 6. So w to the 0th is just 1, and then plus 0. So that is the derivative of this polynomial. I hope this clarified how I use power, constant rule, constant multiple rule, and sum rule to calculate quickly the derivatives of polynomials.